So here's another method for solving simultaneous equations, and we call it the substitution method. And this is a method that's kind of needed to solve the ones with squares, like quadratic ones, when you have like an x squared and y squared. But let me just show you first how we use it on a linear equation, like similar to method 1. But rather than match the coefficients, we're just going to try and isolate one variable. And what I mean by that is we're going to look for like a single positive x or a single positive y. So like I don't want minus x, I want minus y, but if I look at this x, this y here on its own, I can see that it's really useful to have a y on its own, or an x on its own, or whatever letter or variable that you're dealing with. If it's minus, just change all the signs, but if you start dividing to get down to a singular variable and you start getting fractions, then this can get quite a bit messy, so just be careful there, and maybe the matching coefficients method is better. But let's just do this with a substitution method. So we can see this y here is singular and positive, and that's what we're actually trying to get to, so it's kind of already done for us here. So we're going to actually rearrange this a equation, so we have y is equal to, now we're going to bring this 4x guy over to the 7, so y is equal to 7, but now that 4x comes over, he becomes a minus 4x, so that's important, right? So now we've gotten y, if you like, in terms of x, so this is what's normally called when you do something like this. So y is now in terms of x, and we've rearranged equation a to do that. So what we're going to do now is we're going to take this value for y that we got, and we're going to substitute this value for y in the second equation in for y. So we're going to rewrite equation b, and we're going to say, yes, minus 2x minus 2 times. Now, always when you're replacing a variable with something else, it's best to use brackets. Just good practice, because you might mess up your signs otherwise. So instead of y, now we're calling y 7 minus 4x. Okay, and we will close that bracket and equal to minus 2. Now we have one equation and one variable, so this is actually solvable on its own. So let's actually multiply in this 2. Let's do it in some steps here. So we have minus 2x. Now minus 2 by a plus 7 is going to give us a minus 14. A minus 2 by a minus 4x. Well, that's a minus by a minus, giving us a plus. And 2 by 4, giving us 8. And the x, of course. Okay? Equals to minus 2. Now you may be familiar with solving these type of equations. We kind of keep the variable on one side and the numbers on the other, because we're just looking for that one variable. So these two terms here, for instance, are like terms, minus 2x and the plus 8x. So if we bring these together, minus 2x and a plus 8x, it's like 8x minus 2x, gives us a 6x. Now we'll bring over the 14 over to the minus 2. So when 14 comes over, remember it's minus 14, so it comes over to become a plus 14. So now I have 6x is equal to minus 2 and a plus 14. That's going to be a regular plus 12. And then, of course, we just divide both sides by 6 to get rid of that 6 with x. And that gives us x is equal to 12 divided by 6, which is 2. So we've actually got a solution for x, and we can actually put this solution back into one of the original equations. So if you remember in method 1, that's what we said. When we get our solution for a variable, we'll put it back into one of the originals. So let's put this x value of 2 back into equation a, we'll say, right? So let's write a here again. And we're saying 4 times, now instead of x, we're going to use now the value 2. And we're going to say plus y is equal to 7. 4 times 2 is 8. Plus y is equal to 7. Therefore y must be equal to 7, and we bring over this 8, it becomes a minus 8, and y is equal to minus 1. That's it. So we have our value for y, and we have our value for x. So let's bring that on then, and we'll try it in a quadratic equation. So using the substitution one then, it's kind of the only way for us to do these ones here. So what you're going to have to do again, just like the first part, is try and isolate a variable there. So, and we can isolate either here. Let's just go with the x. I mean, x is already positive, already singular, and so is y. I mean, you don't want to go down the route of trying to isolate one of these and getting the square or something like that. So really, it's kind of, this is an easy version. And I'll do some Leaving Cert exam questions, but really the method's exactly the same. Just the numbers might be a little bit trickier, but it's going to be no different to how we do this one. So let's work on this one. Let's first look at equation b, the linear part, say. So generally in your Leaving Cert, in the ordinary level, you wouldn't have two quadratic quadratics, like you'd have just your linear one and your quadratic one. As I said, so like if you're a junior start looking at this video, you're not going to get this, you know. So let's just isolate one of these, just for easiness sake. Let's just isolate this x here. So if we have x plus y is equal to 3, well then it's fair to say that x must be equal to 3 minus y when we bring over this y here. Remember, he changes sign. So now we've isolated x, he's on his own, he's positive and he's singular. So now what we can do with this x is we can replace this x here in for this x here, right? So this is where our algebra skills are going to be tested. So let's replace this x by 3 minus y. So the equation A now is going to look like this. It's going to be 3 minus y instead of x. But remember, that x was squared, so this stuff must be squared. And then we have plus y squared, and we have equal to 5. Okay, we need to square out this bracket. Be super careful here. I often see people squaring the first part and the second part. I think they're done, but that's completely not right because they're separated by this subtraction symbol. So let's say this is going to be 3 minus y by 3 minus y. So there's a whole method to this, and you may know it this by this, this by this. So hopefully you're all comfortable with this. If not, just go back to some Algebra 1 examples and you'll see. So I can do it quickly in my head. It's going to be 9 minus 6y plus y squared. And then we have another y squared out here, and we have equals to 5. Okay, so this now looks like a regular quadratic equation with a single variable. Yeah, we would be used to x's, but it's no problem having y's. Now, just as a tip, a general kind of thing I always say for quadratic equations, the way we solve quadratic equations in our course is bringing it all to one side and setting it equal to 0. And kind of always keeping this quadratic part positive. It's the best way for us to do it. So let's do that. So we can see that we have two squared terms. We have a y squared plus another y squared. So we have two of these. So literally we have 2y squared. That's those dealt with. We have a minus 6y. Now, we have a 9 and a 5 over here. But of course, when I bring that 5 over, it's going to become a minus 5. So 9 minus 5 gives us this plus 4 here. And that's equal to 0. So we're down to something familiar that we know. So to solve this, yeah, it's two brackets kind of situation to solve this. If you're still unsure with that, there are methods like guide numbers, split and repeat, and this type of stuff. But, I mean, use the minus b form if you're really stuck here, and that's the whole other section, I know, but I mean, for this, you probably, if you can do it in your head, it's much better. One thing I will say to you here, solving these type of quadratic equations, we can actually divide these down to make it a bit simpler looking. So what we can actually do is we can divide each term by a common denominator here. I know that term may be frightening some people, but it'll make your life easier. We can see these are all divisible by 2. So if I actually divide this stuff by 2, I will get y squared minus 3y and then plus 2 equals to 0. So maybe those of you that are comfortable now solving these in your head may say, ah, this is a bit easier. So two brackets. And remember again, you can use minus b formula here if you want. Obviously, I do these every day of every week nearly. So it's going to be minus 2 and minus 1. So we're out here, and remember, these are the factors, so they're not the solutions. So we have to take the outside to be the solution. So y is going to be equal to 2, or y is going to be equal to 1. Alright, so we have two solutions. So usually what we do maybe in all the steps, we'd say either y minus 2 is equal to 0. That's why you change the sign. But if you don't want to think about that, just remember, take the thing out and change the sign. Alright, so now we have two solutions for y, and of course quadratic always has two solutions. But what happens here is, yeah, we're done with the y, but we're not done with the x yet. So yeah, it's a little bit more work to this. So what we have to do is we have to come up with our two pairs of solutions now. So how you would write it is like this. So let's go with the first one, y is equal to 2. So you kind of would say this, look, when y is equal to 2, so what do you do here? Well, go to the linear one and replace that y by 2. So when y is equal to 2, that would imply that x plus, and replacing that y by 2, is equal to 3. And therefore x is equal to 3 minus 2 when that comes over. So 3 minus 2 is 1. So that's your first pair of solutions. When y is equal to 2, x is equal to 1. We have another pair of solutions because we also, it turns out that when y is equal to 1, another pair, that would imply, and again we're going to replace this y in equation b by the 1. We're going to say x plus 1 is equal to 3. And of course, when he comes over, it becomes minus 1. So x is equal to 3 minus 1, which is 2. So there's our two pair solutions. So for this quadratic and linear equation, yep, it turns out that when y was equal to 2, x must be 1, and when y is equal to 1, x must be 2. If you put those numbers back in these original equations, you'll see they work. So a bit tricky, a lot written down here, but if you can stick with it and take your time, practice will get you there, and you can probably skip over a lot of these lines I've done here. They're just for demonstration purposes to help you understand. Okay, so I hope that helps.